Welcome back to Making AI Make Sense. Today, parameters. You've heard the numbers. GPT-4 has 1.7 trillion parameters. Claude has 200 billion. Companies throw these around like obvious badges of superiority. What does that actually mean? And why isn't bigger always better? Let's figure this out. Parameters are AI's horsepower metric. Car companies brag about horsepower because it's simple and impressive. AI companies do the same with parameters. But unlike horsepower, where people at least understand it relates to engine power, parameters are completely opaque. Companies assume everyone knows what they mean. They don't explain, they just flex. And everyone defaults to bigger number equals better. Except that's not how it works. Quick honesty check. If someone asked you right now to explain parameters, could you? Beyond bigger number equals better? Most people can't. The AI industry throws around numbers but rarely explains what they represent. If you don't understand parameters, you can't make informed decisions about AI tools. You're just trusting marketing hype. By the end of this video, you'll know exactly what parameters are, why size isn't the whole story, and how to think about the model size for your use case. Quick foundation. AI is pattern completion. It predicts the next token based on learned patterns. No thinking, just pattern matching. So here's the question. Where are those patterns stored? When you type once upon a time and AI continues with a story, how does it know that's the right pattern to activate? The patterns have to live somewhere, and that storage system is parameters. Parameters are the library where all learned patterns live. This changes how you think about model size. Here's an analogy. Two people are writing essays. Person A has a children's dictionary with 5,000 words. Person B has an unabridged dictionary with 500,000 words. Who can write more sophisticated texts? Obviously, person B. More words available means more precision and nuance. But for simple tasks, person A's dictionary is perfectly adequate. Writing sandwich instructions doesn't need 500,000 words. And person A might finish faster because they're not searching through hundreds of thousands of entries. Parameters work the same way. More parameters mean more capacity for nuanced patterns. But you don't always need maximum capacity. Let's get precise. Parameters are numerical values learned during training. They encode every pattern the model knows, which words appear together, how sentences are structured, what follows once upon a time, mathematical relationships, logical connections. A 7 billion parameter model stores 7 billion pattern relationships. A 175 billion parameter model stores far more subtle distinctions. But this is storage capacity, not intelligence. It's the size of the pattern library, not reasoning quality. You can have a massive library of mediocre patterns or a focused library of highly relevant patterns. Size doesn't automatically equal quality. This is why parameter marketing is misleading. Here's another angle. Parameters are like neural connections in a brain. Your brain has roughly 100 billion neurons with 100 trillion connections storing everything you've learned. AI works similarly. More connections means more sophisticated pattern storage potential. But burger brains aren't automatically better at every task. A chess grandmaster's brain isn't larger than yours, it's trained differently. The connections are optimized for chess patterns specifically. It's the same with AI. Sometimes a smaller model trained on relevant patterns outperforms a larger general model. What does this mean practically? Small model with 7 billion parameters, faster responses, lower cost, less nuance, runs on smaller hardware. Large model with 175 plus billion, it's slower, it's expensive, it's more nuanced, it requires massive infrastructure. Neither is objectively better, they're optimized for different priorities. The question isn't which has more parameters, it's which trade offs make sense for what I'm trying to accomplish. Parameter count alone is misleading. It tells you storage capacity without telling you whether that capacity is relevant to your use case. Here's something critical to understand. Parameters are set during training and then frozen. Training starts with random values. The model knows nothing. Then it sees billions of text examples and parameters adjust to capture patterns. Word relationships, sentence flow, concept connections, all encoded. Then the training ends. Parameters locked in place, fixed, done. When you use ChatGPT, you're not teaching it anything. Your conversations don't update parameters. You're querying a static pattern database created at a specific point in time. Bigger models come with real costs marketing ignores. Speed. 175 billion parameter model takes 3 to 5 seconds, where a 7 billion parameter responds in under a second. Cost. Thousands of dollars per hour to operate. Someone pays for that. Memory. Hundreds of gigabytes of RAM just to load the model. Energy. Significant power draw with real environmental impact. Latency. In real-time applications, extra seconds compound. 20-turn conversation adds 40 seconds of just waiting. If a smaller model solves your problem adequately, bigger is just a waste. You're paying more, waiting longer, using more energy for capability you don't need. Here's scenarios where smaller wins. Simple classification like sentiment analysis. 7 billion parameter model is just as accurate as 175 billion. Domain-specific work. A specialized 13 billion medical model beats a general 175 billion at medical tasks. All 13 billion parameters are focused on medical patterns. The large model spreads parameters across everything. Most of that capacity is irrelevant for medical work. Real-time applications where speed matters, smaller wins. High-volume applications. Cost savings multiply across millions of requests. The skill is knowing when you actually need extra capability versus wasting resources. But there are scenarios where you do need the larger model. Complex reasoning connecting distant concepts across multiple steps. Nuanced writing with sophisticated style and subtle tone. Broad knowledge work covering many different domains in one model. Fine-grained understanding telling apart similar concepts. Novel combinations connecting disparate ideas creatively. The principle: if the complexity of the task should match the complexity of the model. Writing a novel with layered characters? You probably need a larger model. Categorizing customer service tickets? You probably don't. Most people default to the biggest model, assuming it's always better. That assumption costs money, time, and efficiency for no benefit. Here's a comparison. Medical diagnosis assistance. Option A is a general large model with 175 billion parameters. It knows everything about everything. Because the patterns are spread across all domains, it's mediocre at medical specifics. It's expensive. It's around 2 cents per request. It's slow, 3 to 4 seconds. It might hallucinate medical facts confidently. Option B, specialized medical model with 13 billion parameters. It's trained specifically on medical literature and clinical data. All 13 billion parameters focused entirely on medical patterns. It's cheaper, less than a cent per request. It's faster, under 1 second. It's more reliable within its domain. Which would you choose? Option B is better in every way that matters for medical work. This is why parameter count as a primary metric is misleading. Okay, time to bust 2 myths. First, more parameters means smarter AI. A 175 billion model is objectively superior to 7 billion in all ways. Wrong. More parameters equals more pattern storage capacity. Whether that helps depends entirely on the task. A 500-page encyclopedia isn't better than a 50-page field guide if you're identifying a bird right in front of you. The field guide is specialized and perfect for the task. The encyclopedia has more information, but most of it's completely irrelevant. Storage capacity doesn't equal intelligence. Here's the second myth. Parameters directly store facts. This model has 175 billion parameters, so it knows 175 billion facts. Also wrong. Parameters store patterns and relationships, not facts. A model with billions of parameters can still hallucinate confidently. Remember video 3? AI generates plausible text, not true text. More parameters equals more sophisticated pattern storage, not more truth. The patterns might be wrong. Training data might have contained errors. AI might activate patterns that lead to plausible sounding nonsense. This is critical. More parameters does not equal more truth. Parameter count is just one spec. Two models with the same parameter count can perform very differently. Architecture design, how parameters are organized, matters enormously. Training data quality affects what patterns get learned. Training techniques impact optimization. Context window size determines how much text the model sees. Fine-tuning adds specific adjustments. All of these factors interact. A 70 billion parameter model can outperform a 175 billion on specific tasks because of superior architecture or better training data. Judge models by results, not specs. Test them on your actual tasks. Here's a practical framework for choosing model size. How complex is the task? Simple classification doesn't need massive models. How much does speed matter? Real-time applications favor smaller models. What's your budget? Larger models cost more per use. At high volumes, these costs multiply significantly. Is it domain specific? If yes, specialized smaller models often beat general larger models. What's the volume? A few cents per request becomes thousands of dollars at scale. Here's the principle. Start small. Begin with the smallest model that might work. Test thoroughly. Only move to larger if you've hit clear limitations. Most people overestimate how much model they need. The AI industry itself is realizing this. Early focus was make it as big as possible. Companies competed on parameter count, but that's changing. The current focus is make it as efficient as possible while maintaining capability. Optimize for performance per parameter. Celebrate smaller models that perform well. The future isn't just bigger models, it's smarter, more efficient models. Companies now compete on efficiency, achieving similar performance with fewer parameters, faster speeds, lower costs. So let me tie all this together. Parameters are the storage system for patterns. Numerical values learned during training, encoding everything the model knows. Set once during training, then fixed. Size is a trade-off. More parameters, more nuanced patterns, but slower and costlier. Fewer parameters, faster and cheaper, but less nuanced. The decision principle, match model size to task complexity. Start small. Only scale up when you genuinely need additional capability. Parameter count is one metric, but far from the only thing that matters. Architecture, training data, optimization, domain focus, all can matter more than raw size. So now you understand what parameters actually are and why size isn't everything. In our next video, we're going to look at temperature and randomness, why AI gives different responses to the same question. Then we'll cover tokens, how AI processes text, and why that matters for costs and limits. These 3 videos give you complete understanding of how models work under the hood. And if this AI education is valuable, subscribe for more. And if you need help choosing the right AI tools for your business needs, visit eauclaireai.com. Thanks for watching, and we'll see you in the next one.